question 19. The density of apple juice is 1.05 grams per centimeters cubed. The density of fruit syrup is 1.4 grams per centimeters cubed. The density of carbonated water is 0.99 grams per centimeters cubed. 25 centimeters of apple juice are mixed with 15 centimeters of fruit syrup and 208 centimeters of carbonated water to make a drink with a volume of 320 centimeters cubed. Work out the density of the drink. Give your answer correct to 2 decimal places. Okay. So we've got, remember, the triangle: mass, density, and volume. So I have that triangle there. So apple mass is going to be 1.05 times 25, which gives us 26.25. Then fruit syrup mass equals 1.4 times 15, 21. Carbonated water, which I'm not going to spell in full, carbonated water mass 0.99 times 280, which is 277.2. So the total mass, if we add those all up, is going to be 324.45. So the total volume is going to be 320. And so the density is going to be M divided by V. So that's going to be 324.45 divided by 320, which is 1.01 grams per centimeters cubed to decimal place. 0.01. Okay, next. So 21, show that these triangles are mathematically similar. Okay, so let's take, so if we say that, for instance, those are the angles. So 7.5 divided by 3 gives us 2.5. 10 divided by 4 is 2.5, and 12.5 divided by 5 equals 2.5. So all sides have the same scale factor. Okay, next question. Question 22. So complete the table complete the table values for y equals 6 over x. Okay. So basically we'd say 6 divided by 0.5 was 12. That's already been done for us. 6 divided by 1.5 is going to be 4. 6 divided by 3 is 2. 6 divided by 5, 1.2. 6 divided by 6 is 1. So on the grid below, draw the graph of the values. So let's just zoom out ever so slightly. A different color. So let's do this as follows. So I'm just gonna bring this up slightly. Okay, so we have on the y, we've got 1, and then we've got 6. So that's the first one. Now, because I'm using a graphic tablet, it's going to be a bit hard for me to be very precise, but essentially you're going to have coordinates 0.512, 1, 6, 1.54, 2, 3, 3, 2, 4, 1.5, 5, 1.2, and 6, 1. And you're going to mark very precisely, unlike what I've done there, but very precisely. So that's 1, 6. Okay, and then so on and so forth. So 5, 1.2. So it might be slightly futile for me to do it because it won't be very precise, but essentially you plot all of the points, and then here it's going to be 12. So just bear in mind that you have each of the squares here equates to 2. So 0.2, so this is 10.0.2, 10.4, 10.6, 10.8, and then 11. Whereas here, the squares equate to 0.1. So we've got 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 0.8, 1.9, and 2, and so forth. So just be wary of that. But anyway, suffice to say, you draw it out and then you connect the curve. And then the final question. So Harley's house has a value of 160,000. Correct 2 significant figures, being the 1 and the 6. Write down the least possible value of the house. So if we draw something like this, so I'm just going to put 160k because I don't want to keep writing out the zeros and for space. So 170k, 150k. So can have 165k, 155k. So write down, so the least possible value would be 155k. I mean here k represents 1,000, so just be conscious of that. And write down the greatest possible value of the house. Well, it could be 165. I'll actually write it out properly here. We'll do the same for this. You don't want the examiner thinking, why did you put K? The value of Rita's house increased by 5%. Her house then had a value of 210,000. Work out the value of Rita's house before the increase. So her house went up by 5%, which is 105% of the new value. So if you divide this by 105, divide this by 105, you will get 1%. So you get 2,000, and then divide by 105, and then here you times by 100, which will give you 100%, which will give you 200,000. So the answer is 200,000. And that brings us to the end of the paper.